start the recording. So dear student, just wait. So in the previous session, we have discussed this flow chart. That is, what are the processes are to be carried out for a water treatment plant. Okay, so aeration, pre-chlorination, channel flow measurement means we have to measure the whatever the flow which is to be analyzed. Then alum mixing, as I have told you, coagulation is to be carried out. Okay, then flocculation means flock is to be settled out and whatever the treated water is present at the top. Okay, then filter process. Different filter layers are present into the filter chamber, and various layers, filter media is present over there, and filtering is carried out. Okay, and then outlet flow measurement. That means we have to analyze the quantity of water which is coming out, and then post chlorination. This general layout I am showing you. So that we have already discussed. And you have to note that whatever the processes are to be carried out, which is very much important on the basis of whatever analysis of raw water is carried out. Okay, we have to check the quality parameters of our collected raw water, and then you have to decide the line of treatment, as I have told you previously, isn't it? So today we have to discuss regarding aeration. Okay, so aeration is a very much important process. Okay, can you see the screen properly? Hello.
Yes, ma'am.
Okay, so you have to remember that this is the process of bringing water, and principle of gas transfer is to be used into close contact in order to remove dissolved gases. You know, some gases are not good for our health, so those gases are to be removed out, such as carbon dioxide. You know, atmospheric oxygen when get mixed into the water, it will get purified. Okay, so you have to remember that this aeration is not compulsory, but most of the time 90% we need to provide aeration, because we have to remove those gases which are objectionable. Okay, so in this aeration, which is important operation, and the principle is used. What is the principle? Gas transfer is used in this. Okay, and the process exposing large surface of area. You can see the image, that is the cascade aeration. In this, exposing large surface area, we have to make contact of air with the water. Okay, that is atmospheric air is mixed into this water, and water get purified. Okay, and what are the objectionable gases? Carbon dioxide, as I've told you, H2S, which create lots of odor. Okay, and that gas to be removed out, as well as we have to oxidize some metals like ferrous as well as manganese. Okay, it can also be used for remove volatile organic compounds. Volatile organic compounds means micro compounds which may be objectionable into that raw water which is present into the your collected water. Okay, so we have to focus on this. Okay, so by this image, I hope you understood. Okay, so aeration is the first major operation at treatment plant. 90% time this process is the first operation. You have to provide screening for removing floating matter, but which may be provided, which may not be. Okay, and aeration is also one type miscellaneous process. During this aeration, we have to remove some constituents and modify it before the treatment process. So what are the things we have to focus? What is the principle of air transmission? In that, what happened? Scrubbing action caused by the turbulence of water and air mixing together. You know, we have to scrub. It means we have to make contact of air for air in such a way that when this air, whatever the aeration is process takes place, they are introduce air into water and water into air. Means they get mixed. Okay, so whenever this scrubbing action is takes place, automatically atmospheric oxygen is mixed into the water, and dissolved oxygen content is increased out. Dissolved oxygen. Okay, so this is takes place into this aeration process. And oxidizing certain metals, like as I have previously told you, ferrous. Ferrous means iron. Iron get oxidized. Okay, and precipitation is takes place. Precipitation means that's a whatever the large ferrous is having reddish color, and it get oxidized, and then settlement of that ferrous oxide is takes place at the bottom. Okay, and that sludge is removed. Okay, so oxidizing that metal ferrous as well as manganese is carried out. Okay, this thing is to be focused in this aeration process. So what do you think, what are the objectives of aeration? Objectives, we have to think about this objectives, which is that means in your oral examination, if practical examination you have in this subject, in that you have to face external examination, and that maybe the question may be asked by external, that what are the physical chemical characteristics or biological characteristics present into the water, and they may ask what are the operations are to be carried out in water treatment plant. So that this type of question may be arised. So you have to think about objective of each operation. Okay, so that means aeration have objectives as follows: oxidation of organic matter means, organic matter means which can be degraded. That means food product, as algae, bacteria are present. Those are uh, degradable. So that organic matter is to be oxidized. Okay, because see for example, uh, suppose we have kept bread into on the surface, and after 5-6 days, it have uh, addition of some fungus. Application of fungus or takes place over the bread because of that is organic content, and it get oxidized. So whenever oxidation of organic materials takes place due to air present into the atmosphere, so that is one object. Okay, to increase dissolved oxygen content, as I told you previously. Third object, to reduce concentration of taste, and whatever the objectionable odor. Okay, such as the odor means very bad smell, as well as bad odor takes place due to hydrogen sulfide gas. Okay, and that is reduced due to addition of oxygen. Okay, by volatilization, stripping, or whatever the process we are carrying out. Oxidation have, or the aeration process have various types. Are you getting what I am telling you? What are the whatever the points I am discussing with you? Are you getting? Hello? We'll see in detail different processes, but you have to understand the objective. Okay, to whenever we carried out this precipitation, say ferrous oxide, manganese oxide, it will uh, first of all it will insoluble and then get soluble. So precipitation is very much important, which is carried out due to oxidation, and this oxidation process takes place in aeration. Okay, after that, flocculation of colloids in seepage influent. That means whatever the this flocculation is takes place, that means whatever the suspended and colloidal matter, it will get agglomeration, and this is caused in aeration process. Okay, so the main objectives as we have discussed. So do you know, students, we have to first of all understand what are the types of aeration and why we have to carry out or the classification is based on which thing. So, aerators fall into two general categories. They either introduce air into water or water into air. Okay, the water to air method is designed to produce small drops of water that fall through air. Okay, so we'll discuss in detail in the next slide that in the types of aerators. Okay, Whenever the air to water method creates small bubbles of air that are injected into the water stream. I will tell you in this how the processes takes place, methods of aeration. Okay, so broadly, these methods are gravity aerators, fountain aerators, in diffused aerator, and likewise. Okay, so what is gravity aerator? When we'll discuss this gravity aerator, one major type is cascade aerator. Okay, so by gravity, such whatever the process is carried out, large area of water is exposed to the atmosphere. Okay, sometimes by turbulence, the turbulence is created into whenever we are adding atmospheric oxygen into the water due to turbulence or due to a sparkling, that oxygen is automatically get mixed into the water. Okay, this is caused in cascade aerator. I'll show you the images of cascade aerator as in previous way. That is fountain aerator. Okay, so that is also one cascade aerator, and multi aerator is also one example of gravity aerator. Okay, so these are the two types, major types of gravity aerator. Second, fountain aerator. Fountain means as we always shown in governmental building, there are when we are entering into the government building, in front of that, most of the time this fountain may be observed. So in that, what happened? Water is discharged under effect of fountain aeration, a fountain action, in the form of fine spray, in the form of fine spray, isn't it? So spraying results in the form whatever the formation of extremely minute droplet of water, which increases the surface area of contact with the air. Okay, because of fine spray. Okay, this whenever this takes place by the spray aerators, this the spray aerators will cause into that fountain, and spray nozzles are located in the pool of water. You know, whenever you, in the, I'll show you the image. This fountain aerator, you have already seen this fountain aerator. In that, spray nozzles are located in the pool of water, and they are involving loss of heat. Or loss of heat, we have to check. Okay, the pressure, whatever the pressure for fountain is to be created, which is nearly 0.7 to 1.4 kg per centimeter square. What is that? 0.7 to 1.4 kg per centimeter square. In that, removal of carbon dioxide and hydrogen sulfide is takes place nearly 90%. Okay, so this is regarding fountain aeration. Okay, then diffused aerator. We'll see the diffused aerator. First, we'll see cascade aerator. I have to show this cascade aerator, which consists of series of steps. Okay, series of steps. These are the, you can see the image, series of steps. In all cascade aerators, aeration is accomplished with the splash zones. You know, the raw water is coming into the inlet conduit, and then that inlet conduit means inlet pipeline. Raw water is collected into this inlet chamber, and it is supplied through the concrete steps. Okay, so we have to think about the height, whatever the height of these steps, which is nearly 0.15 to 0.3 meter. So these are the sizes of steps is to be provided. Okay, at that time, whenever which is passing over the these concrete steps, atmospheric oxygen get mixed. Okay, so continuously atmospheric oxygen get mixed, and a removal of carbon dioxide takes place. Removal of hydrogen sulfide, bad taste, bad odor is removing out, as well as some bacteria which are may present into the water. They get, in some extent, they get removed out, or those are kills down by the agitation of water during this process. We have to remember. Okay, so cascade aerators can be oxidized iron, as I've told you, and dissolved oxygen get mixed, and DO content is increased out. Okay, so this is the cascade aerator process. Okay, you can see the nappy. You know very well what is nappy. Okay, so this is the process when we will decide the height of your steps you have to. Okay, this is also cascade aeration is carried out. So where this cascade aerator are also called as free fall aerator. Okay, so whenever we'll carry out the steps, that may be 3 to 4 steps, or sometimes it may be up to 10 steps. Okay, depending upon the whatever the zone which is available nearby your city from where water is coming out. Okay, so water is allowed to fall these steps, as they may be straight as you are observing. There may be, these are the straight steps, that those may be circular as in this image, circular steps. Okay, so these are the cascade aerators. So water is allowed to fall through this uh, altitude. What altitude means? Height. You can see the height. So these are the height we have to when water is passed over this, which may be 1 to 3 meter. Okay, so you can see 0.6 meter, 0.6 meter altitude is or height is present into this, is completely depends upon whatever the quantity of water is coming. We have to analyze the assessment of flow discharge is coming, and what amount of impurity present into that. Depending on, we have to decide the altitude and we have to design those steps. Okay, so design of cascade aerator also you have to know how to design is carried out. So we'll discuss that part later on. First of all, we have to understand what are the types, what are the classification of this aeration processes. Okay, so this is a very nice image of aeration fountain or cascade, circular cascade aeration. Okay, I hope you understood. So when we will carry out this cascade aeration, sometimes riffle or plates, inclined plates are also maybe present through these steps, over the steps. Okay, so that riffle plates are continuously moving. Okay, these may be open in air or under shelter. So you can see this open in air, or it may be under shelter. Okay, after that, we have to discuss the next part, that is trickling bed or multiple tray. Okay, so this is the image of trickling bed. Okay, what is see trickling bed means this is a image. This is the good image, I think. Just multi tray aerator. This is a perfect image. And this you can see in this method, water is pumped into the feeding tank. So this is the you cannot see feeding tank, but I'll show you. Okay, this is the feeding tank, feeding pipe. Feeding pipe is present here, and from this raw water, whatever the impure water is to be, we have to supply. Okay, so through this feeding pipe, which is available at the height, you can see this is high. This height is to be provided, and water is allowed to trickle down. Trickle down means percolation is to be carried out. These are the trays. 1, 2, 3, 4. These are the trays which is present over there. And in those trays, number of pebbles are present. I'll show you again. So you can see these trays. 1, 2, 3, 4. And feeding pipe is available at the top. And water in these trays, pebbles are present. You can see the pebbles. Pebbles means coarser material. Okay, coarser material is present, which are having angular shape. Oh, it may be maybe sand, it may be broke coke or slag of size 5 to 7.5 centimeter or 50 to 75 mm, 50 to 75 mm size. Okay, so that those papers are placed in this trays. Okay, so what is the process? We have to feed the raw water. Okay, from the top it will get percolated or it will be trickled down. Okay, so this water is get trickled down. So whatever the perforated trays, these trays are perforated. Sorry, I forgot to say you. These are the perforated trays. Perforated म्हणजे सच्छिद्र आहेत ते ट्रेला छिद्र आहेत म्हणून ते पाणी कसं होतंय ट्रिकल डाऊन होत आहे. तर तुम्ही बघताय इथे ट्रिकल डाऊन झालेलं पाणी हे सगळं प्युअर वॉटर आहे आणि वरतून इम्प्युअर वॉटर येत आहे. सो collection pan is also present here. This is the collection pan. Okay, so this whatever the papers, whatever the sand grains, coke means एक wooden typeचं मटेरियल असतं ते प्रेझेंट असतं त्याच्यामध्ये, और मे बी ब्रोकन स्लॅब म्हणजे एक स्टोन टाइप मटेरियल असतो तो सुद्धा त्याच्यामध्ये प्लेस करतात. डिफरंट मटेरियल वी कॅन प्लेस. Okay, which having size 50 to 75 mm. Okay, and we have to keep whatever the horizontal bed we are providing here on the this trays. They are having 20 nearly 25 centimeter height. Okay, 25 centimeter height, and whatever the spacing we are providing 40 to 60 mm. Okay, that spacing is to be provided. So so these are the things we have to observe. Whenever we are trickling down water, automatically atmospheric oxygen get mixed, and due to perforation, whatever the objectionable gas is also removed out, and our purpose is solved. Okay, water trickles down from one bed to another, which is, you can see, water is percolated from one to second round, second tray, second to third, third to fourth. This is takes place into this, and bottom collection pan you can see. Okay, so water trickles from down one bed to another, and it is collected finally at the bottom collection pan. This method gives better results of removal of as well iron and manganese also. Okay, which is also seen in cascade aeration. I hope you are getting. This is the actual image or picture of multi-tray aerator, and this is the cross section. Okay, this is the cross section or the picture image diagram of multi-tray aerator. It is also called trickling beds. Trickling bed method. Okay, trickling bed method or multiple tray method. These are the same. Next, spray aerators. So this spray aerators are the aerators. This type of aerator, one or more spray nozzles connected to pipe manifold, which I have discussed with you previously. So you can see these are the cross pipes, and the spray nozzles are attached to these spray nozzles. Okay, so water leaves each nozzle in a fine spray and falls through a surrounding air, which creating fountain effect. Okay, in general, this spray aeration whenever carried out, which oxidizing iron as well as manganese. So this spray aerator is the next type. After that, nozzle, which is also the pictorial image of this spray nozzles. So nozzles, through nozzles means this is the one image. This is also another image. This is the feeding pipe, and through the nozzle, whatever the water, impure water, they get contact with the atmospheric oxygen, and it get fixed. Okay, this is also a perfect image of spray aerator. So fine, whenever I have told you now, 0.7 to 1 kg per centimeter pressure is takes place into the spray nozzles. That is only this, and this helps to remove carbon dioxide and hydrogen gas nearly 90%, and some bacteria also get removed or kills through this process. Spray aerators. This is also one image. Are you getting? Hello? Hello? Please reply. Hello? Hello?
Yes, ma'am.
So this is very simple topic. No need of deep information for this, but you can see through the image you can understand. The main purpose is that we have to remove carbon dioxide and H2S, and we have to precipitate manganese and ferrous, that is oxidation of ferrous and manganese is to be carried out. That is most important. Okay, so the last point, diffused aeration. Whatever the aeration may be carried out by diffused method. By method, network of compressed air pipes is placed at the bottom. Okay, how it is? This is the one image. Means we have to diffuse, for a diffuse pipe is to be present. Okay, and compressed air pipe is to be provided at the bottom. Okay, of the water tank. This is the water tank. You can see the क्रॉस सेक्शन तुम्हाला जो दिसतोय ना, याच्यामध्ये हे वॉटर टँक हे फक्त क्रॉस सेक्शन आहे. त्यामध्ये हे पूर्ण टँक आहे. त्याच्यामध्ये एक हे जो पाईप आहे तो पास केलेला आहे. तर ते त्या पाईपचं नाव काय आहे? कंप्रेस्ड एअर पाईप. सो कंप्रेस्ड एअर वी हॅव टू ब्लोन आउट. Okay, and you can see these are the different pipes in which it is provided, and nozzles are diffused plates are provided. Diffused plates. These are the diffused plates. Diffuse plates, and this is the compressed air pipeline. Compressed air pipeline or pipe is provided. Okay, and this is the water tank. Okay, so in this method, network of compressed air pipes are placed, which is provided at the bottom. Okay, and compressed air is blown through the perforation. You can see the perforation. Okay, perforation is provided at the perforated plates. These are the plates. So air, obviously air whenever is passed through this pipe, compressed air blown out, and it get mixed into the water tank. And whenever this contact takes place, atmospheric oxygen, this oxygen of dissolved oxygen of this water is increased out. जसं जसं आपण हवा मिक्स करू, एअर मिक्स करू, तसं तसं इथली जी वॉटरचा जो डिझॉल्व ऑक्सिजन कंटेंट आहे तो ऑटोमॅटिकली वाढेल. Okay, so the air bubble travel upward through the water, cause whatever the process, turbulence is created, and which will bring aeration. So we have to provide this compressed air blowing is takes place, and sometimes we have to provide the nozzles also. The nozzles पण कधी कधी लावतात. The suitable nozzles are fitted to this compressed pipe. Okay, and air make contact with the water, and this process is carried out for 15 minutes. For 15 minutes, detention time, theoretical retention time of air mixing takes place for at least 15 minutes. Okay, so whatever the depth, you can see the depth of this tank, which is nearly 3 to 5 meter. Okay, 3 to 5 meter depth is to be provided. So this is continuous flow type of. कंटिन्युअस फ्लो टाईप मीन्स इथे 15 मिनिटं झालं की नेक्स्ट त्याला इथे आउटलेट असतं या साईडला, आणि आउटलेट मधून ते नेक्स्ट याला जाईल. कुठे जाईल? फर्स्ट एरेशन नंतर सेकंड प्रोसेस असते सेडिमेंटेशन. सेडिमेंटेशन द प्रोसेस दॅट वॉटर इज सप्लाइड टू सेडिमेंटेशन. ओके, सो दिस इज image course. In this, diameter approximately 2 mm to 2.5 mm of a pipe is to be provided. So bore surface area per unit volume is to be present. Okay, so coarse bubble aerators means तेच आहे. त्यामध्ये coarse जो काही bubbles आहेत त्यांचं diameter जास्त असून ते अशा पद्धतीने diffused air system provide केली जाते. Okay, so this is also one image of diffused air system. Okay, I hope you understood diffused air system. Some pumps are available whenever some revolving fan is attached to the water tank. Whenever revolving revolution per minute is to be decide, and at that time atmospheric oxygen is get mixed. That is mechanical aeration. So this is one image of diffused air system. This is mechanical aerator, whatever I'm telling you. Mechanical air means we have to provide this pump, and we have to carry out revolution of these plates. So this, whenever it will get revolved, atmospheric oxygen automatically get mixed. Okay, this is also one type of aeration, mechanical aerators. Okay, cone aerator. Cone aerators nowadays not used. but we have to discuss. Co-aerator are used primarily for oxidize or iron and manganese. So you can skip this co-aerator because nowadays they are not in use. They're obsolete. Air into water. What is air stripping? That I have to tell you. What is air stripping? It is quite effective removing volatile organic compounds. You know, volatile organic compounds are they may be present in a dry cleaning process. Dry cleaning process, or what are the sources of volatile organic compounds in air condition? They're also removing out. So these VOC are benzene from gasoline and trichloroethylene, which may be present in a dry cleaning establishment. So they may enter into the water whenever we are carrying out our raw uses of water. Okay, so we have to remove those. So that is nothing but the air stripping. So air stripping is whenever this process is carried out, it can be accomplished by letting water flow over cascade aerators or in specially designed air stripping towers. Water allowed to flow down over a support medium or packing, as we have seen in the trickling bed method. Okay, so this is the process. So, what are the common operating problems in completing this operation? Supersaturation, slow removal of hydrogen sulfide from the towers, algae production. Sometimes algae get mixed. Suppose some uh, green algae may be present if we are not maintaining that process properly. Okay, sometimes this filters clog, just like we have seen in multiple tray. So at that time, suppose organic matter is in large amount, त्याच्यामध्ये फंगस लागतो, म्हणजे क्लॉगिंग होते. म्हणजे जर फंगस खूप जास्त झाला तर तिथे काय होईल, फिल्टर्स तिथे क्लॉग होतील. तर त्यामुळे आपल्याला काय करावं लागेल, त्याचं मेंटेनन्स करावं लागेल. ओके, ओव्हर यूज ऑफ एनर्जी, दॅट इज ऑल्सो वन प्रॉब्लेम. म्हणजे आपल्याला पंप चालवायचा आहे तिथे, जेव्हा आपण डिफ्युज एरेशन करणार आहे, कंप्रेस्ड एअर ब्लोन करायची आहे, तर तिथे एनर्जीचा ओव्हर यूज होऊ शकतो. सो दीज आर द कॉमन ऑपरेटिंग प्रॉब्लेम्स ओके इन दिस मेथड. वन मोर थिंग, सपोज डिझेल ऑक्सिजन कंटेंट जास्त झाला तर तिथे सपोज तुमची जी काही पाईपलाईन तुम्ही यूज करताय ती आयनची असेल तर तिथे काय होईल, तिथे करोजन होईल. सो करोजन मे बी टेक्स प्लेस ड्यू टू ओव्हर ऑक्सिजन. So these are the common operating problems in aeration. So that is not important. We have to understand what are the process takes place in this aeration. Okay. Operational testing means what we have to check: dissolved oxygen, pH, and temperature. Continuously we have to check dissolved oxygen. Dissolved oxygen is to be checked by Winkler's method. You don't know that method, which to be studied in the wastewater engineering or your environmental engineering part 2. Okay, how to check dissolved oxygen. But nowadays digital diometers are also present. Directly within seconds, DO can be measured out. Okay, then pH by pH meter, we can check pH, and temperature by thermometer. So these are the things we have to check continuously when aeration processes takes place. Okay. Hello. Hello.
Yes, ma'am.
Yeah. So these are the things we have to focus. Next, guide for choosing an aeration. What we have to focus when we are choosing aeration system? Obviously, we have to focus on cost, service condition, versatility, and mechanical design. That means if suppose we are designing cascade aerator, we have to provide the steps. If suppose we have to go for the trickling beds, then we have to make arrangement of papers, slab, broken coke, sometimes broken your brick material. So that we have to carry out the availability, and when we have to think about the depth of those trays. We have to think about the what are the sizes of different trays, as well as if you are focusing on cascade aerator. So accelerator should have a proper diameter of aeration fountain. So these are the things we have to focus. Okay. So this is the difference, diffused aeration, mechanical aeration. We'll skip that. So just wait. So diffused aeration technology and mechanical aeration technology we have to focus, because nowadays in modern technique mostly those systems are used, diffused aeration or mechanical aeration. So advantages are superior mixing, major energy saving, possible flexibility in capital cost. These are the things are focused on diffused aeration as well as mechanical aeration. So I'll share you the slide, because only 2 minutes are remaining. So I'll share this study content. You have to study down. Okay. So whenever we are carrying out mechanical aerator, mostly mechanical aerators are also nowadays carried out in your wastewater treatment process. Also, mechanical aerators are used, because at that sewage is to be treated out. Then sewage are having large amount of odor, which is objectionable odor. H2S gas is removed continuously. So at that time, mechanical aeration is mostly provided. Okay, so this is to be focused, which will be the better option. Okay, so in the next part, we'll see regarding sedimentation. Okay, so whenever you will focus on design of castrator in your online examination, design may not be asked. You have to focus on objective questions, multiple choice question. Then also I have shared you the content in the Moodle, so you can see there. Okay. So I hope you understood the concept of aeration process, and you have to think about what are the processes are to be carried out, which are widely used, which are majorly used. Okay. So types again. See, in theoretical, whenever you have to write down the answers, you have to focus on images, figures, diagrams. So these are the figures which can easily draw, and you can easily understand what are the things and what are the processes are carried out. So this is multi-layered. इथे सर्क्युलर आहे, बस जो काही एरेटेड माउंटेन आहे तो सर्क्युलर आहे. बाकी जो आपला मेन प्रिन्सिपल आहे तो एकच आहे. त्याच्यामध्ये ट्रिकल डाऊन करायचं आहे. वॉटर इज टू बी ट्रिकल डाऊन.